Welcome to Section 6, Strategies for Improving Model Performance. This is Lecture 21, which is upsampling the minority class with SMOTE. So I've retrained our optimal XGBoost classifier, and we can see we've detected 43 instances of fraud. We know that we've got 3 false positives and 6 cases of fraud that we missed, right? As we know, the original data set is highly imbalanced. So the vast majority of our samples come from the non-fraudulent distribution, and our labeled instances of fraud only accounts for less than 1%. So it's a very, very small minority in comparison with the majority. And one of the popular approaches for improving our model performance in these scenarios is to upsample that minority class using something called SMOTE, which allows us to generate synthetic copies of the fraudulent class in order to upsample it so that it will improve model performance and model generalization, etc. So in order to do that, there is an implementation in the IMB Learn library called Oversampling, and the SMOTE algorithm specifically that we can import. Then we also import the collections library just for the purposes of the counter so that we can compare before upsampling and after upsampling. We can look at the amount of fraudulent cases within our training set, right? So with this line, I'm just printing out what the distribution is between the minority class and the majority class. So we can see, 443 fraudulent classes within the training set. Then I'm initializing the SMOTE object. I've set the sampling strategy to 1. So this is a hyperparameter that you can play with, where it allows you to control the ratio between the minority class and the majority class after upsampling. So with the sampling strategy of 1, it's going to match your positive or your minority class with your majority class. So if we've got 250,000 of the majority class before upsampling, after upsampling the minority class, we'll end up with the same 250,000 records. Obviously, we can dial this ratio up and down depending on our strategy, but effectively that hyperparameter is just the ratio of minority to majority after resampling, right? Then the K nearest neighbors is another parameter that we have access to. By default, the setting is 5. Effectively, that defines the neighborhood of samples that we use to generate our synthetic samples, and we can decrease that in order to reduce false positives if we do find that we end up with too many false positives in our new model after upsampling the minority class. All right, so once we've initialized that model, then we can assign it to a variable, and then on that variable we can say fit resample to the original training data, so the X and the Y, and we can assign that to 2 new variables, which is the resampled X, so our resampled features, and our resampled target variable, and then we can apply the counter again just to see the distribution between the 0 and the 1, and now we can see they're aligned, so there's a 1-to-1 matching. This isn't always the best approach. You can, only upsample by a much smaller fraction if you'd like. This might be overkill. It might be creating too many false positives for your model. That's fine. This is just something that you can play with. So if it's, 10% of the majority class, if you want to upsample to that fraction, that's totally up to you. There's no right approach. All right. Then what I've done is I've retrained the model with the new resample data. It's the exact same model configurations from the previous model, so max depth of 5. We've upscaled the minority class at training time as well, and then this is the confusion matrix that I'm getting, right? So in this case, I've managed to detect 1 more instance of fraud, So we've gone from 43 to 44, but at the expense of incurring a few more false positives. So that might not always be an optimal strategy. Again, as we know, we can apply a cost-based approach when we can, assuming that additional fraud case saved us enough money that we were happy to accept the increase in false positives, that's fine. But we already had captured so many fraudulent cases with the original model that there wasn't really a huge opportunity for improvement. So in some sense, we might be overfitting a little bit. So maybe we can dial it down a bit, reduce the sampling strategy to a much smaller fraction, and then potentially not use the scaling of the positive weight as well within the model hyperparameter, because we've already, using synthetic data, upsampled the minority class.